I will just quick introduce the schedule and a little note of housekeeping. If anyone's here doing a professional development requirement, if you leave your forms and you just put them in the back on one of the tables in the back, I will, after the fact, sign them and have them available in my office so that you can come pick them up. Does that work for everybody? Just so because people might be coming and going at different times, so if you don't mind, that might be the easiest way to do it. Okay, so here's the schedule for this afternoon. You'll see it's an enormous amount of material, so we're going to try to encourage everyone to be very concise about how they're presenting this and be exciting and engaging. It's a little bit of a celebration for us, so please join us in trying to encourage that type of setting this afternoon. So this is the schedule and the outline. We're going to hear from the group that's working on projects in Panama. For the presenters, there is a mic here because we are recording this, so if you just stand in this general vicinity, that's the best location for getting a good audio. Okay? So then we're going to talk about the projects in Nicaragua. Two projects there, water and health. We're going to talk about a couple of projects in Cambodia. The Ghana project, where we're working on sustainable hand pumps, a new initiative in Madagascar, where we're going to be deploying summer interns to spend 2 months there. Talk about a few projects in India, where we've been partnered with Profugo for a number of years, and then we'll have some closing remarks. And anyone who wants to join us afterwards can join us in the Dean's Conference Room in 210. For sort of an informal get-together. Some of the students that are presenting here will stick around and we can chat with them somewhat informal. So perhaps we can turn it over to Seth and Marissa. And Seth, if you don't mind, the standard format would be to introduce the next group. If that's okay? Or just call them up and
So hi everyone, I'm Seth and this is Marissa. This year we kind of took the lead with the Panama project, which is one of the longest running projects that we have here at Villanova. We initially became involved with it in 1992, and ever since the early 2000s, we've been going on trips, generally over fall and spring break, down to work on water projects and other infrastructure projects. And you can see a picture of the setting in the background. It's located in a rural region of Panama, called the Alto Bayano region, and a little bit into the Darien region, which is actually right before Colombia. So it's a very rural jungle area.
So we're fortunate enough to work with an amazing project partner, Father Wally Kasubascu, and he is a Capuchin missionary priest. He's been in the region since 1988. He is a lawyer, he has a construction company, he runs a rice farm, so pretty much anything he can do to support the local people he does, and he really strives to work on 3 areas of service. Water, so that people can be healthy; roads, so that they can get where they need to go, especially during the rainy season is a big issue in the region, and then education, so that the people can kind of work on their developing their opportunities through that.
So with these 3 areas that Father Wally likes to focus on, we try to provide technical assistance in any way that we can, really. We've worked kind of on all 3 of those sides. And this past semester, or this past year rather, we've done this mostly through projects working with water, chapel design, and bridge design. So with the water, there's 2 main systems we work on, the Pigandi water network and the Canyasas water network. Canyasas is a water network that's been in place since the 90s when we first became involved with it, and it serves water to over 5,000 people in the area. So it's really impactful and broad-reaching, and it's made up of over 100 kilometers of laid pipe, so it's also very extensive. However, they have been experiencing pressure problems in it with pipes exploding, and then in other places with not enough pressure and negative pressures occurring. So it's became this really complex problem that we sought to analyze and come up with a solution to. And then the other water project is a new design that we're working on a little bit east of the area in Pigandi. And this, we're designing a new water system that's using pumps and gravity to distribute water to about 80 homes. And then on top of that, Father Wally had a couple of sites he wanted to build a new chapel. So we had some senior capstones working on a design for that. And then we were also working with the design of several new bridges.
So as Seth mentioned, we're working on multiple projects, and we were able to, through the different programs that are working on the Panama project, get a lot of deliverables over the past year. So for the water projects, to address the pressure problems in the Kenyasa system that Seth was mentioning, we have developed and designed a break pressure tank to sit halfway down the mountain that the system is located on to break the pressure, essentially, and to relieve the pressure problems downstream so that you won't have burst pipes and disrupted water delivery. The other thing that we're working on, and we have submitted a design for him, is for the new system of pumps in Pigandi. And with that, we have, you can see in the picture in the top right here, that's from the Pigandi system. And we are redesigning the structure for the tanks to sit on that hold the water for that network, as well as designing a pump system that will deliver enough water and pump it up, because the source is located below these tanks here. So we need to design pumps to move the water up to the tanks so that they can be delivered to the homes of the surrounding region. So those are two designs that our Villanova Engineering Service Learning weekly meetings have put together over the past semester or two. And then the senior capstone design groups from the civil engineering department have also come up with designs for chapels and bridges in the area to address the other issues. So you can see one of the chapels that's being built in the lower left there.
So while the opportunity to work with these engineering problems is really great in like giving a real world problem to our engineering education, definitely another huge part of these trips is being able to interact with the community and meeting the people that you're going to be working with. And in the Alto Baiano region, there's a really great mix of communities that we work with, ranging from the Embera tribe, which a lot of these pictures right here of, who's a native tribe in the region that our water system goes to. But on top of that, there's also just about 13 different communities that we work with. So we get to see people from all different types of life and meet them and get to know a little bit better about the communities that we're working with. And it's definitely one of the most valuable parts of all the trips we go on.
So for us, these trips and the opportunity to work on these projects has been incredibly beneficial. As engineers, we get to apply things that we've learned in the classroom to real life problems and deal with issues from working in the real world and working in the field and trying to adjust and adapt with what materials you have and what labor source you have available, and trying to take all of those considerations into account when we're making our designs. It's also amazing to see what you can do with a Villanova engineering degree and what impact you can have on these communities. And finally, I think it's influenced, I know it's influenced mine, and a lot of people that have gone on the trips with us have said that it's changed their viewpoint in regards to their future and how they want to really use their engineering degree, not just, to engineer just anything, but really to make an impact and a positive impact, whether it's locally or internationally. So it's been a great experience. If you have any questions, you can contact Seth or I. Our emails are up here, but thank you so much.
Thank you. And next. And next up, we will have a group from the Nicaragua project.
Hi, everybody. My name is Adam Butler. I'm a senior mechanical engineer, and I'm going to be talking about the trip to Waslala, Nicaragua, and with the water project and the organization Water for Waslala. So just to give you a little bit of background about the organization, Villanova partners with two different groups. The first is an American NGO called Water for Waslala, which was started by two Villanova graduates with the hopes of designing and building water systems in rural Nicaragua to provide clean water to the local community members. Now, what Water for Waslala does is they provide technical recommendations to a local partner as well as fundraising for all of the designs of the networks. Now, the local partner is a group called ADIS, which is a Nicaraguan NGO, and their job is all design, construction, and implementation, maintenance of all the systems on the ground. So we worked directly with ADIS when we went in the springtime, and there's two trips. There's one in the fall, one in the spring. I went on the one in the spring. So now this is a short video clip, if it works. This was done by the fall group, and I'll give you a little snapshot of what these projects are like. Do we have sound, Jordan?
Pause for a second. Try again.
You ready to go?
We're gonna do the little strip tests here.
What are we doing here exactly, Chloe?
The municipal system has a lot of problems and it doesn't get water to all the pumps all the time, especially during the dry season. But the dry season flow measurements that I've seen from the source that goes to this tank is like more than enough in the town to meet. The problem is that this tank just fills up really fast overnight. Yeah.
Nice. How's everyone feeling? Pretty dry right now? Yeah.
It's really not what you would expect. So I was there over the summer and it was very technical based, but going back with a bigger group, it was more about like connecting with the community and just letting them know that we know the story and we haven't forgotten about them.
She really changed the way I looked at things. Trying to be worrying about your health and what you're eating, what you're drinking, because like in years to help, this could be hours away.
A couple people who stood out to me, and I'd say definitely Virginia was one, just because she's just the sweetest woman, and what she taught me was your passions are really what drive you and make you happy no matter what your situation is. And I think great things are going to come to Virginia just because of the amount of passion that she's showing for what she does.
The trip was a lot more cultural based, and I learned a lot more about the Nicaraguans than I did about engineering the week that we were there. We really don't know much at all compared to what they know, like Teleno and those ethics, more stuff that I'll ever know.
I guess it was just a partnership with the people there, because in a lot of cases you go there, you clean house, you learn about, the poverty situation, but you don't work towards really creating change. This was, we were there to educate so that from then on, they can test the water on their own.
Playing soccer with the kids when we were on, was pretty, probably a highlight of the trip for me. It was just kind of cool to see that, everyone just kind of working together.
If we hadn't gone, people would still be drinking that water.
And further, if we didn't have the organization there dedicating to eradicating this crisis, people would continue to get sick from this water and their lives would be cut short.
People in Waslala, they don't live in like, you know, a consumerist society like America. They survive. When you're surviving there, they're getting water for their families, which is like a necessary thing we take for granted.
I'll just get you on.
Okay, so that was a little snapshot from what the group in the fall did. In the springtime, we worked on 3 different projects after the trip. One project was a team worked on promoting the Walk for Waslala, which is the main fundraiser for the organization. It happens every year here on campus in April, in the springtime. So look out for that next year. It's a great event. This year we were able to make $19,000 for the organization, so pretty big fundraiser. Another group worked on designing a suspension bridge for a pipe to cross a river in the network. Another group worked on designing a new, selecting pipe sizes for a new network in a town called Los Mangos. And as you can see on the right there, that's what the network is going to look like. All those green pentagons are houses. So these networks can do a lot of good for a lot of people. So thank you very much. The next group is the wireless network group in Nicaragua.
Hi, so I'm Mauro, and this is actually my senior design project. It's a wireless network in a community in rural Nicaragua called Sabana Grande. So it's a relatively new project, just started last year with my senior design. And our partners are the community itself, Sabana Grande, and UNI. And it's also important to note that Dr. Singh actually just signed a grant with UNICEF, so we also have a partnership with them as well. The Sabana Grande community, they're a rural community surrounded by mountains on all 4 sides, so they're in a valley completely surrounded by rough terrain. There are a lot of farms, and grid power is sparse. Cell phone access exists in some parts, but it's also sparse, and there's absolutely no internet access anywhere. But they do have a strong need and a strong desire for internet access, and that's for education. There's over like 500 students in the community that actually their teachers expect them to access the internet for their homework, but they have no access to the internet at all. And for health and as for communication and weather as well, you know, they get a lot of dangerous weather and flooding in the valley, so it would be really helpful to get weather alerts via the internet. So the problem is that the signal is blocked by mountains. That's why they haven't been connected yet. And the sparse grid power makes it difficult to design repeating stations to bounce the signal either over the mountains or around the mountains. And of course, the remote location also means maintenance is difficult. So it's hard to build a repeating tower if you know that eventually a piece of it is going to break, and it might be very difficult to get a new piece out to the repeating tower in a difficult area full of rough terrain. So our solution was to use MATLAB models to find the optimal antenna positions and actually power the repeaters with solar panels so they wouldn't have to be connected to grid power, and use all locally available parts that everyone in the community would, or that the community leaders who would be maintaining the system would be able to access and replace if needed. So just a quick overview of the design specs. So I'll actually just go back. We're connecting at Kazuka Mountain. We purchased a 3 megabit per second connection, and we're actually bouncing the signal over the blocking mountain range to another mountain on the other side of the community called Solar Mountain, and then we're actually sending it back then there into the community. So from Solar Mountain, it overlooks the entire community, and you can, from there, you can connect pretty much anywhere in the community. So where we're at now with this design is we're trying to use these models to find where the optimal tower location should be so that we can hire local contractors to install a repeating tower and use this repeating tower to get the signal that we need. So we do that in MATLAB, and we use these models with where we map out the land and map out the link and the waves propagating between the link, and then compute how much interference there is between the two antennas. So just a little output graph, an example. So I'll just go right into talking about the people, because the people are really amazing. It's probably one of the coolest places I've ever visited. Completely changed my life and the way I think about the world and my perspective on the world. They're the most nice and welcoming people I've ever met. We went there to visit their community, and immediately they welcomed us in, let us stay in their houses, cooked us food. It was really, really amazing how friendly and how nice these people were. There's tons of students, and a common theme in a lot of the families we talked to was that everybody wants their students to go to college. A lot of them, that's kind of why they work on the farms and why they do everything they do. It's for their kids, because they want their kids to be able to go to college. And to go to college, their kids need to pass standardized tests and go to elementary school, where the teachers expect them to actually be supplementing their learning with the internet. So that's helped give the project a lot of meaning and really motivated us to question why this community hasn't been connected, and then provide a good engineering solution. So it's just a couple pictures from the project. There's the senior design group down at the bottom. Up there, that's actually all of the trip from last spring, everybody that went on it. You have on the right side the Uni students, and on the left side there's all the guys from Villanova. Partnering with the Uni students is really a great thing, just to it was really cool just to see people, other engineers on the other side of the world that are just so much like yourself. And I know I made great friends with the guys in my group, and we couldn't have been able to do these designs and make these projects without them. And then up top you have the mountain, and then our MATLAB model of the mountain with some antennas on it. And that's pretty much it. So if you have any questions, I'm Morrow. My email address is up there, and you can contact me. So feel free to do that. And next up we have the Cambodia group. Thank you.
All right, hi everyone. My name is Alex. I am a first-year graduate student in mechanical engineering. My colleagues, we got Mike Benson over here. He's a senior mechanical engineer, and Carrie Franchino, who is a junior mechanical engineer. So this past winter break, we had the privilege of traveling over to Cambodia for 2 weeks. And in Cambodia, we were leading 2 different projects. The first one, Mike will go into a little bit more detail about. That is developing a low-cost explosive ordnance disposal robot. And the second project, which Carrie will go into, is a STEM workshop at a rural middle school that Cambodia is partnered with. But before we go into the details, I always think it's really important just to give a little background, a little setting to some Cambodian history, because it's really relevant to why our projects matter. So in the 1960s, late 1960s and 70s, Cambodia was heavily involved in the Vietnam War. And then immediately following that, a communist group known as the Khmer Rouge forcefully took over the country, led by Pol Pot. And they, in order to hold power, they actually they hunted down a lot of the educated class in the country and ended up murdering them, hundreds of thousands of people. And in addition to that, Cambodia, as a result of both of the armed conflicts, it's estimated that today there are millions of unexploded ordnance scattered throughout the country. And that includes anything from landmines to rocket-propelled grenades to full-size bombs. So as a direct result of both those, or as a direct response to both of those projects, I'm going to hand the presentation off to Michael Benson, who will go a little bit more into.
Sure. So the project partner for ours was a group called Golden West Humanitarian Foundation. They're a worldwide non-government organization, but the group that we specifically worked with was based out of Cambodia. And they really specialize in remediating this UXO, or unexploded ordnance problem, that is a problem not only in Cambodia, but also in places like Laos, or all sorts of other places around the world. And they're really focused on research and development into technologies to address these problems. They have specialty programs in mine detection technologies, munitions stockpile destruction, and they have a really cool explosives harvesting program that I won't get into, but if you want to check it out, you're more than welcome to. The cool thing is that they consist of a large number of former EOD technicians. These are people that have served in Afghanistan or Iraq in recent years, and have had firsthand experience dealing with this stuff with modern technologies that something like the U.S. Army uses. So as we can see on the bottom right, that's kind of one of the more commercially available EOD robots. So this is something that the U.S. Army would have, or some comparable developed nation's army. The problem is these cost anywhere from $100,000 to $500,000, require lengthy service contracts, and they're really just not practical for a developing country. And then when you get to countries like Cambodia or Laos or something like that, how they address problems like landmines or unexploded ordnance is you pretty much just have people with little to no training going around with pokers, either trying to safely detonate these things or at least find them and they'll be addressed in some way later. So the question becomes, how do we take some of this robotics technology and take people out of the field, but be able to do it at a price point that's acceptable for a developing country? So this is how we came up with the Villanova University Engineering and Golden West Humanitarian Foundation EOD robot. Principle is to design one of these as a low-cost alternative to some of these more expensive robots. It's a balance of the cost, functionality. This needs to have 80 to 90% of the operating functionality of one of the commercially available ones, and also be reliable in the field. It's not going to break down easily when it's used by someone that doesn't have extensive EOD training. The price point that we were looking for is to be able to manufacture this for under $4,000, and then it would potentially be sold from anywhere from $8,000 to $10,000. So this has been a senior design project for a couple years now, and this year myself, another member of my team, and Dr. Clayton were able to travel to Cambodia, where we were able to meet with Golden West, do some field testing at their site, and really connect with the EOD technicians while we were there and figure out what exactly are we dealing with, what do we need to do on this. And overall, it was a huge success. We were able to meet almost all the design specifications that we were looking for, and they're so pleased with it. We're going to have one more senior design team, and they're looking to actually put this into production somewhere around the end of 2016. So this is a service learning project that is actually going to go out into the market and be available worldwide for developing countries to purchase to address UXO problems.
Okay, so then the other half of the group, we spent some time with them, but then we went to the rural north and we taught elementary, middle school students certain things like about the engineering process. Really got to work with them. So this is a picture of the little school. Some of the past years got to design the preschool and build it, so we've been there several times, but this year we took it in a different direction and went more STEM related. So some of the science projects, we wanted to give them sort of a really broad engineering background. So Alex helped them design and shoot rockets. So they made an air compressor and they got to watch them explode, and it was really exciting. What I did with them is I let them design little rubber band cars. In the middle, you can see like one of the really cool ones. They have little flags on it. And then they raced them, and we gave them some candy and stuff for the teams who won. It was all about being creative and innovative while also learning about energy and velocity, things like that. We did water quality testing, sort of a generic thing with all these projects because it's really important and crucial in these places. We did boat buoyancy testing. And at the very end, we had this big tower competition where whatever team, we just gave them bamboo sticks and tape, and whoever could build the tallest tower that could support weight and stuff would actually be sponsored to go to Phnom Penh this past March, the main city, for the National Science Fair, the first National Science Fair, actually sponsored by the same company that the senior design worked on. So these are some pictures. They sent them to us. We couldn't go there in March because that happened to be our spring break or during midterms. But these are some pictures. They did some of the projects we did with them at the science fair. They had a fabulous time. They absolutely loved it. And one of the kids that with the family we're staying with in Cambodia said that it was the most fun he ever had. I go, oh yeah, school's fun. He goes, no, this is the most fun I've ever had. We're like, wow, that's kind of sad, but that's awesome. We got to be a part of it, which was really incredible and life-changing.
Just some more pictures of the actual STEM workshop that we had. At the top left, that was us racing. Top left and bottom right is us racing rubber band powered cars. On the top right, you can see the buoyancy test that we had them build like boats and then kind of throw rocks in there and whose boat could hold the most rocks, that sort of thing. And then I just wanted to say at the end, in addition to the huge success of both of our trips this past break, we also had a lot of fun getting to travel around the country. Bottom left, we spent New Year's in Phnom Penh, which was amazing. Top left, we got to swim in an actual like a volcanic lake. We got to explore Angkor Wat, go visit some temples back in the jungle, rent motorcycles. Like this is like one of the best trips I've ever had in my life, and I've been on quite a few now. So yeah, that's pretty much everything. Wrapping up. If you guys have any questions, feel free to contact any three of us. We are having continuation, as Benson said, the EOD project is continuing next year, as well as there are opening slots in the workshop for next year's trip, if that's something that you're interested in. So with that, thank you very much for listening, and we're going to pass the project off to Ghana.
All right, good afternoon. Thank you all for being here, and thank you for giving us the opportunity to talk about our trip to Ghana. I'm Jared Sessom. I'm a graduate student in the Master's of Science Sustainable Engineering program. I expect to graduate in a couple weeks, so this is a really exciting time for me.
I'm Paul Christensen. I'm a sophomore mechanical engineer.
So, yeah, we last October during fall break, Paul and I traveled to the country of Ghana in West Africa with Professor O'Brien, along with a team of 5 from our partner organization, including Mr. David Powell, who's here with us and is the founder of the organization. We did water monitoring water monitoring of the water services there in Ghana, and our work focused on doing assessments in a rural region of southeast Ghana called the Volta region, and we did assessments of the handpumps that have been installed there over the past 9 years.
So I'm going to talk a little about Wells for Relief International, which is the nonprofit organization we went to Ghana with. They were founded in 2004 by David Powell and Mark Mills, and they run completely by donations, and with these donations, they use them to finance the installation of water projects, infrastructure management, and maintenance. Also, they use these funds to create educational programs in these locations in order to educate the locals on how to maintain and fix and run these water projects. So the locals create like a sense of ownership of these water pumps and the project as a whole, and thus make them more sustainable. Wells for Relief started in Morocco and later expanded to the Ghana area. They created a partnership with Lifetime Wells in 2006, and Ghana, Lifetime Wells has been in Ghana since September of 2006, and they have created over 800 water wells. And they also have projects in Tanzania where they already have about 200 wells. Along the years, they have successfully given water to over 500,000 people. clean water.
So I don't think it's a surprise to anybody in this room that we have some serious issues with water scarcity in the world. And there's 300 million people in sub-Saharan Africa who are suffering from the effects of water scarcity, according to the World Health Organization and the UNICEF Joint Monitoring Program. So with population growth and climate change increasing these issues, we're fortunate to have organizations like Wells for Relief, along with Water for Waslala and thousands of other organizations around the world who are taking action to provide sustainable infrastructure to help alleviate this problem. This work's provided access to clean water for people in developing nations where they're hardest hit by this issue, and it's helped decrease child mortality rates from waterborne illnesses, as well as improve the quality of life for women and children who spend a significant amount of their day fetching water. So Paul and I were tasked with visiting as many villages and hand pumps as we could over a 5-day period to track the location of the hand pumps that have been installed by Wells for Relief using GPS device, and conducting a survey with the village chief or whoever was there and willing and available to speak with us. So our assessment was based on the STEEP model of comparing the performance indicators of functionality, reliability, quantity, and quality of the water from the hand pump, compared to social, technological, environmental, economic, and political factors associated with the project. And data was collected for over 200 hand pumps and analyzed over the past few months to apply a sustainability rating for each project, or for each site, based on the criteria shown here, and had a different service level and color-coded rating associated with that. All the hand pumps were transferred over to Google Maps as well as ArcGIS from the GPS devices, and this is some of the results for the first 185 hand pumps that were analyzed, and I'm up to about 205 that have been assessed or analyzed from the data that we collected. And these figures are pretty resemblant of what we're at still. There's only a difference of a couple percentage points for each of the performance indicators. So, we found a strong correlation between functionality and financial management of the water systems. Communities that set up a water service management team and collected a fee for the use typically had higher sustainability ratings because they had the funding to repair broken systems and maintain the systems over time. And the other notable issues were water quality, where there were some areas where water was salty and people wouldn't pay for it. They used it for cooking and cleaning, but since they couldn't drink it, they didn't want to pay for it. And then reliability was another issue. If the hand pump broke down often, then they wouldn't want to contribute money for repairs. So this resulted in about a third of the hand pumps that have been installed being non-functioning currently. So the community and the people were amazing. We visited over 100 villages each, and we had the opportunity to work and meet with some amazing people. Paul and Professor O'Brien went out with Bob, who is a pump mechanic in country, hired by Wells for Relief, and they focused on Ketu North District, while I was in Ketu South with the gentleman Vincent, who's up in the upper right-hand corner. He was involved with the initial installation of all the hand pumps and provided education and outreach for hygiene and sanitation to all the villages, and was also part of the training for financial management and operation and maintenance that went into the installation program. First thing we heard when we went into any community was Wezo, which means welcome. And the pineapple signifies that, and like we heard from some other groups, everybody was very welcoming with regards to offering food. I mean, they're cutting fresh coconut for us and feeding us pineapple, and which is amazing when you consider they have so little. So it was really interesting to see their way of life, from their farming practices to how they make money. There's an example of that in the bottom left corner with weaving of kente cloth, and how they prepare their food. And visiting schools was really interesting to see their classroom structure as well. So Paul.
So yeah, as Jared said, the people were extremely hospitable in all of these villages we visited, and the experience was extraordinary, as other project members have said. It's like a life-changing experience. We really take for granted that like water is so accessible for us. These people in these villages had to walk miles and miles just to take dirty water from a pond or from a puddle or whatever. The conditions were very, very bad, and just that like these organizations are doing this well and making life a lot more healthier and easier for them. It feels very good to be a part of it.
And for me, this experience has offered incredible perspective of the interconnected challenges we face in the world, but it also shed some light on solutions that we can offer as engineers to help people around the world. And it's not only significant opportunity to help with water accessibility, but they have challenges with electricity and waste management as well. And Wells for Relief has also started installing pipe scheme systems with mechanized pumps, so there's opportunity for solar powered mechanized pumps as well. And we've had I had some requests for irrigation systems in a couple of villages, and there's a picture of a site where they wanted to have another hand pump installed in the bottom right hand corner there. So there's no reason for people to have to go to a dirty water source or dig a 20-meter hole down to the aquifer like this gentleman's doing in the bottom right here as well. So another notable observation was the culture shock that I realized coming back to the U.S. And one thing for sure is that we can use a whole lot more contentment and appreciation for what we have here. So I'll just leave it at that. That's all we have. So thanks for your attention. There's our contact information. Feel free to contact us or check out the Wells for Relief website if you like additional information.
Thank you.
Hi everyone, I'm Tara Malenga. I'm a junior biology and French major, and I'm thrilled to be traveling to Madagascar this summer to act as a French translator as part of the partnership project between CRS and Villanova. This partnership is aimed at creating sustainable access to water in the country of Madagascar, which has a lot of trouble with access to water because of the country's great poverty. People might not know that Madagascar is one of the poorest countries in the world, and there, as a result, isn't a lot of infrastructure in the country. So many people don't have access to potable water supplies, and so the aim of this project is to increase not only access to potable water supplies, but also to help create greater hygiene in the country. The access to water has been particularly bad, especially since the early 2000s, when control of the water sector in the country was turned over from the federal government to local communities. And as these local communities have very little funds because there is no real taxation in the country, the communities have just not created any sort of way to grant their population with access to water. And so the goal of Catholic Relief Services in Villanova is to help pair up these local community governments with private organizations in what is known as a public-private partnership in order to install water supply systems and to maintain these systems, which has been one of the major issues. So far, this project has achieved great success, allowing 81,620 people with access to sustainable access to potable water. And this has been enabled by the installation of 10 functioning gravity-fed water supply systems and 239 functioning hand pumps. In addition, hygiene in the country has been increased, as is shown by the data that 17,858 household latrines have been installed, which has allowed for 105 villages to become certified as open defecation free, which is a big step for the country because open defecation is still widely practiced. Additionally, 10 community water and sanitation business plans have been created as a result of this project, and this shows how granting people with access to potable drinking water enables not only increases in sanitation, but also increases in business, which can help the country to further develop. On Villanova's side of the project, there's much graduate research that's done in order to determine ways to create sustainable development. This is done through a number of research fellowships. Through this research that's done here at Villanova, and also through field visits that have been undertaken by faculty, including Dr. Etienne Achille, who you see in the top right-hand corner. Technical briefs have been created and programs and plans for installing these water supply systems within the country and the best ways of installing them and maintaining them have been created, and then students as well as other representatives from Villanova have gone over and will continue to go over, just like our group who's going this summer, in order to help show the community what has been learned through the research done here in order to create greater access to water. This will help to increase the capacity of these communities to reach sustainability goals. Personally, I will be working alongside students from the business school and the engineering school, and I will help to translate because Madagascar is a former French colony, and so not only do they speak their native Malagasy language, but they also speak French, so I'll help to create exchange between the people in the country who are helping to install these systems and the students and other faculty from Villanova who will be assisting.
Hi, I'm Rebecca Connolly. I'm a sophomore civil engineer.
Hi, I'm Sarah Bates, and I'm also a sophomore civil engineer.
And this past winter break, we had the opportunity to travel to Kerala, India, which is in the south, with 2 other engineers and Tyler Castile, who's a field fellow through Profugo. So our partner was Profugo, which is a nonprofit international development organization that is actually centered in Ardmore, so it's right down the street. And their work is mostly focused in Prashantagiri, India, which is also in the south of India. And most of their work is development projects that empower the local community members. So some of their initiatives are a tailoring center for the women to work on so they have more consistent work throughout the year. There's also the construction of wells, so there's better access to clean drinking water. And then what we mostly focused on was the implementation of biogas digesters. And Profugo is really big on the community working for itself rather than other people coming in and kind of just giving them a project to work on. It's more the community sees a need and they work on it with community members. And so most of the time we were there, we were directly interacting with everyone in the community. So whether we were just like walking down the street, like people would yell out of their homes and say hello to us, invite us in for tea. Like chai was a huge thing there, like you always had it. And then everyone was just really interested in what we were doing, and then they were kind of just wanted to tell us all about themselves too. So we were always immersed in the culture, which is very nice. So then we also had the opportunity to work on some individual projects, which we weren't anticipating. We kind of saw a need and then we found a solution to it. So Sarah and I worked on an incubator for Petri films for the water quality testing. So we started out with just like a cardboard box and like mud for insulation, and then we left a design project for the local engineering students to work on to kind of make it a more sustainable project for them to work on and just learn from that. Then Akash worked on a water distiller. He like cut a beer bottle like that he just like found and used it to, you put the water in and you get clean water out, and that water was used for our total dissolved solids testing. Christina worked on the water level indicator, which was definitely a need that like just needed to work on. So she set up a system that would monitor the water level, and then if it reached a certain height, a light bulb would go off so you'd know how much water was inside the tank. And this was a big thing when it would rain too much and the tank would overflow, but the pump would keep going and the pump would blow out. And then when that happens, you can't get the water out of the tank, and then people are, like, they don't have any service to water because multiple families would use one tank. So this is kind of just to prevent that from happening. And then all of us worked on a water quality testing lab where we worked with the local children, and they came with us for one day and we showed them all the equipment to use. We told them what contaminants could be in their water, and it kind of allowed them to become leaders in their community because they were more active in what was going on. They were more aware of the problems that were there. So I'll just give a brief overview. This was our biggest thing that we worked on there, which is biogas. And biogas digestion is when you take waste, so we use cow waste, and you mix it with water to form a slurry, and you put it into this apparatus, and then you collect the methane that comes from it, and you can use it from cooking. So the dome is constructed out of steel rebar, chicken wire, and cement. And then the reason this is so important is because the traditional way of using fuel in the kitchen was like wood and fire, and that's just not healthy when you're in a very closed room and there's smoke everywhere. It's just health problems. Or an alternative one was propane, and that's just ridiculously expensive. So this is a more efficient and sustainable way of using fuel in the kitchen.
All right, so we arrived in India for phase 2 of Profugo's biogas initiative. So when we arrived, there were 3 biogas digesters already up and running, and we got to witness and help out with the construction of 3 additional digesters. So we helped to shape the dome out of steel rebar, and we applied layers of cement with the local mason. And it was amazing to watch him because all of his work is done by hand, and it's all from memory, and he has no written plans. While we were in India, we also were able to do some data collection, which was great. We got to interview families about the efficiency of their gas and the gas burn time, and we asked them about any problems they were experiencing and if the gas was produced enough to fit their daily need. We also asked them about what they were putting into the biogas digesters. And in most cases, it was measured in terms of buckets of cow waste and water. So back at Villanova, we came up with 3 things that we'd like to continue working on. One is feedstock. We wanted to research more additional feedstock options to make the biogas digesters more efficient. We also wanted to look into materials because the materials that they use to make the biogas digesters now are very expensive, and so better materials and more cost-effective materials would be great. We also wanted to look into compressing and scrubbing the gas. This semester we connected with Dr. Duran. He's an environmental engineering professor, and he's very knowledgeable about anaerobic digestion. And he really helped us to direct our research, and we narrowed it down to just feedstock with our limited amount of time, and we narrowed it down to banana peels. Banana peels are very common, very readily available in India, so that's why we chose banana peels. To begin our research, we measured the volume of, we got bananas that were similar to the ones that we had in India. We measured the volume and calculated the density of one banana peel. We then made a slurry out of banana peel and water and used that to perform a volatile solids test. And then from that information, we came up with 3 samples that we'd like to test. One is a control sample with seed from a wastewater treatment plant to facilitate biological activity. The other 2 had different concentrations of banana slurry mixed with seed. and there were triplicates of each of those, so we had 9 samples in total. And just today, we put all 9 bottles in the incubator, and over the course of the semester, we will be measuring the biogas production, and we will use gas chromatography to measure the methane production. Our final goal for this semester is to be able to convert our amount of banana peels to something tangible that villagers can measure, so like in terms of buckets or containers, of what they can put into their biogas digesters to make them more efficient. In the future, we'd like to, in addition to our other research initiatives like compressing and scrubbing and looking into materials, we'd also like to test additional feedstock options and maybe do some co-digestion tests. We'd like to thank Profugo, Dr. Duran, Tyler Castile, who was the Villanova alum and field fellow that went with us, and Jordan for helping us facilitate all of this. And this project has been an amazing experience for learning, and if anyone is interested, we'd like to keep the momentum going. So please reach out to us if you're interested in any of the things that we talked about. Thank you.
Okay, so I would like to thank everyone for coming. This has been a really nice time and a good way to pull all of these pieces together in the same room and ultimately kind of see what everyone else is doing. It's pretty exciting for us this is the first time that we've done this. And frankly, I think it's really important to mention a couple of things here. One, we have the opportunity and the luxury of engaging in these type of projects for 2 real important reasons. One is the project partners that we work with, right? The people that do the day-to-day grind in the country, the field partners, the people that are doing the implementation of these projects who live and breathe these problems on a 24-hour basis. Without them, without their support, without their efforts, without their champion initiatives, we wouldn't have anybody to be of service to, right? And I think everyone will agree that once you sort of engage in these type of projects with that type of mentality and that type of humility, you often walk away from it feeling more fulfilled and having received more than you've given. So that's something that sort of seemed to be a common theme across the board. And without them, frankly, we wouldn't be able to do any of this. And at the other level of this, people that are worth thanking and recognizing is the project partners and sponsors, right? People that either support us directly or support our project partners. Particularly at the sort of advisory level, at the US-based level, people like Profugo, who I think has a team who's here, people like Wells for Relief, Water for Waslala, the Karamanico Foundation, the Golden West Humanitarian Foundation, Father Wally and his Chepobayano mission, and did I forget anybody? I don't think so. Catholic Relief Services, right, and the teams of people that have been supporting all of these initiatives with the CRS program. Frankly, all of their initiatives have put us in a position where we can actually be of service. And without that, we would really have nothing, right? So I really, really, from the bottom of my heart, want to thank all of those entities, all of those stakeholders, all of those partners. And one other thing that's worth mentioning is the incredibly unique opportunity and experience that we've all had and that we're all having at Villanova, right? Without sort of this idea, this mission-driven type of thing at the university here, we wouldn't have the type of administrative support to do any of this, right? The insights, the faculty that have been sort of motivated by the students, have been motivated by these issues, that frankly won't take no for an answer when it comes to certain things. I often say that, or people will ask me, and sort of when we're talking to faculty, people will say, why is it that you do this, right? I mean, you've seen this sort of global tour, this world tour of initiatives and issues and challenges and frustrations and frankly, this human celebration of just life, right? And people will say, why do you do this? Why do you continue to do this? And I think any of the faculty and anyone with an engineering background or anyone that's sort of involved or interested in this type of work will probably agree that when you know the right thing to do when you're faced with an issue that you feel that you're qualified to address, it's actually harder not to do something about it or not to try, right? That is something that is sort of engaged me and has continued to engage me personally in getting involved in these projects. And I think at least the faculty that have been involved in this work kind of are also driven by that, right? It's when you're an engineer and you have a background in this, it's frankly harder not to do the right thing than it is to just do the right thing. So I hope that you can all use that as a takeaway. And if I could just thank the faculty and some of the people that are here directly, maybe just put your hands up and we can kind of applaud them to say thanks to them and the students with all your incredible hard work. We would not be able to do any of this without this excitement and this general interest. So thank you guys. I want to thank you guys as much.